Every industry has been touched by COVID-19 impact. This pandemic being challenged especially while constructing. As we know, asphalt closely related with construction industry and mostly used in pavement construction. Currently, there's a lot of technologies that we can take advantage of. The asphalt using in pavement construction has a lot of innovation and development to have less of an impact on environment.
To learn from you, Dr. Izzy.
Every industry has been
And in
touched
fact,
by
I would like
COVID-19
to apologize as well
pandemic
because I
being
can
challenged,
only
especially
stay for
when
about
constructing.
1.5 hours and then I leave
As we know,
because I need to go
asphalt
to
closely
attend
related with
an
construction
event
industry and mostly
later
used
on.
in pavement construction.
So I may
Currently, there's
disappear
a lot of
earlier before the
technologies
end
that
of
we can take advantage of. The asphalt using in pavement construction has a lot of innovation and development such as eco-friendly manufacturing, which being developed to
Alhamdulillah,
have less of
Alhamdulillah,
an
everything
impact
is
on
good.
environment.
How are you over there?
Alhamdulillah, everything's fine here.
Okay, Madam Rita Susanti, can you hear us? Or can you check your audio?
Okay, hello, Mr. Hasan. Yes. Selamat petang, Dr. Yusuf, Dr. Izzy.
Every industry
Good
has
morning.
been touched by COVID-19 impact. This pandemic being challenged especially while constructing. As we know, asphalt closely related with construction industry and mostly used in pavement construction. Currently, there's a lot of technologies that we can take advantage of. The asphalt using in pavement construction has a lot of innovation and development such as eco-friendly manufacturing, which being developed to have less of an impact on environment. Every industry has been touched by COVID-19 impact. This pandemic being challenged especially while constructing. As we know, asphalt closely related with construction industry and mostly used in pavement construction. Currently, there's a lot of technologies that we can take advantage of. The asphalt using in pavement construction has a lot of innovation and development such as eco-friendly manufacturing, which being developed to have less of an impact on environment. Every industry has been touched by COVID-19 impact. This pandemic being challenged especially while constructing. As we know, asphalt closely related with construction industry and mostly used in pavement construction. Currently, there's a lot of technologies that we can take advantage of. The asphalt using in pavement construction has a lot of innovation and development such as eco-friendly manufacturing, which being developed to have less of an impact on environment. Every industry has been touched by COVID-19 impact. This pandemic being challenged especially while constructing. As we know, asphalt closely related with construction industry and mostly used in pavement construction. Currently, there's a lot of technologies that we can take advantage of. The asphalt using in pavement construction has a lot of innovation and development such as eco-friendly manufacturing which being developed to have less of an impact on environment. Every industry has been touched by COVID-19 impact. This pandemic being challenged especially while constructing. As we know, asphalt closely related with construction industry and mostly used in pavement construction. Currently, there's a lot of technology. Every industry has been touched by COVID-19 impact. This pandemic being challenged especially while constructing. As we know, asphalt closely related with construction industry and mostly used in pavement construction. Currently, there's a lot of technologies that we can take advantage of. The asphalt using in pavement construction has a lot of innovation and development such as eco-friendly manufacturing which being developed to have less of an impact on environment.
Assalamualaikum warahmatullahi wabarakatuh. Shalom, Om Swastiastu, Namo Buddhaya, Salam Kebajikan, Salam Kebaikan. Good afternoon, ladies and gentlemen. Welcome to the International Seminar Expert Speak Series 2021, Adaptation, Infrastructure and Design During and Post-Pandemic.
Respectable the head of Civil and Architecture Department, Vocational School, University of Diponegoro, Mrs. Asri Nurdiana, STMT. Honorable our speakers today, Associate Professor Engineer Dr. Nur Izi Yusuf from the University Kebangsaan Malaysia, Honorable all of the lecturers of Civil and Architecture Department, and all of the committees and also all participants who attend this event. First of all, let's say thanks to Almighty God who gives us guidance, happiness, health, and mercy so we can gather here in this special event without any obstacles.
And before we open this event, let us introduce ourselves first. My name is Dio and my partner.
Saya Salsabila Jusudana Putri.
Going to be your master ceremony and accompany you from the beginning until the end of today's international seminar. On this special event, we have several agendas as follows. Opening, compulsory song, welcoming speech, rules, opening video, main agenda, games, and closing.
Ladies and gentlemen, before we come to the main agenda, let me start this by praying first so that the event will hold this day will run smoothly without an obstacle at all. Pray based on individual belief begins. And pray is done.
Ladies and gentlemen, National Anthem of Indonesia, Indonesia Raya, and continued by listening Mars University of Diponegoro. For all participants, we thank you.
Ladies and gentlemen, here we go to the greeting speech from the head of Applied Bachelor Program Civil Infrastructure Engineering and Architecture Design Vocational School, Diponegoro University, to respectable Mrs. Asri Nurdiana, STMT, Time and Screen are welcome.
Oke, terima kasih atas waktunya. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, everyone, and good day to all of us. First of all, we would say thank you very much to the speaker today, Dr. Izzy from University Kebangsaan Malaysia. Thank you, Dr. Izzy, for your willingness to stand here with us today and share the knowledge to our students. And thank you for your kindness to the speaker today. And it's an honor for us today also because we have special guests today, Dr. Iswandaru. Thank you for joining us. Okay, I am Mrs. Asri, the head of the Department of Civil and Planning Vocational School, Diponegoro University. This seminar is held in 9 sessions every week and special discussion about construction during this pandemic. And the topic of today is about asphalt innovation and will be delivered by Dr. Izzy. Okay, the last to the participant. Yeah, I believe that today's seminar material is very important for us to know. So please concern to this seminar and take a lot of knowledge. Okay, thank you for the time. Wassalamualaikum warahmatullahi wabarakatuh. Thank you.
Thank you so much to Mrs. Asri Nurdiana, STMT, for the greeting. Next, we have Rules of Expert Speak Series 2021. Tata tertib Expert Speak Webinar Series. Yang pertama, tata tertib umum. Peserta masuk ke dalam Zoom meeting maksimal 15 menit sebelum acara dimulai. Peserta wajib mengikuti dan mematuhi arahan yang nanti dibacakan oleh pembawa acara, baik Master of Ceremony maupun moderator. Peserta diwajibkan on-cam selama acara webinar Expert Speak berlangsung. Peserta diharapkan mematikan mikrofon untuk menjaga ketertiban keberlangsungan acara dan mengaktifkannya ketika ada instruksi. Peserta wajib mengikuti seluruh rangkaian acara webinar Expert Speak dengan baik. Peserta yang mengalami suatu kendala bisa lapor ke narah hubung yang sudah tersedia. Peserta dilarang melakukan aktivitas yang dapat mengganggu konsentrasi pemateri dan peserta lainnya. Peserta diwajibkan menggunakan virtual background yang telah disediakan oleh panitia. Peserta wajib mengisi link absensi dan pada barcode yang akan diberikan oleh panitia di setiap sesinya, dan jika mengalami kendala saat absensi, peserta dapat memberitahu secepatnya kepada narasumber.
Tata tertib sesi tanya jawab. Peserta yang ingin bertanya wajib mengaktifkan fitur Raise Hand dan memperkenalkan diri sebelum bertanya dengan ketentuan nama dan instansi. Penanya diharapkan menyalakan mikrofon untuk menyampaikan pertanyaannya. Apabila terkendala pada mikrofon, penanya dapat menuliskan pertanyaannya melalui kolom komentar yang tersedia.
All participants are requested to obey all the rules. Ladies and gentlemen, here we are presenting to you an opening video of Week 7 Expert Speak Series 2021.
During the pandemic that hit the entire world, including Indonesia, this resulted in almost all human activities being paralyzed due to the physical distancing program launched by the government in order to reduce the spread of COVID-19, which was increasing day by day. This COVID-19 virus brings a lot of change in construction industry, which have a big role in pandemic and post-pandemic era. Construction industry must have an innovation for its buildings, such as adapt to a new technology, which also help our country to be more advanced.
And moving right along, we have the main agenda for this afternoon. The material about asphalt innovation from our special speaker, Associate Professor Insinyur Dr. Nur Izi Muhammad Yusuf from University Kebangsaan Malaysia, and hosted by our lecturer, Mrs. Riza Susanti, STMT. And before we moving to the main agenda, let me read out our moderator CVs first. Mrs. Riza Susanti, STMT, graduated cum laude in Sarjana Teknik Sipil Undip in 2011 and graduated cum laude in Magister Teknik Sipil Undip in 2014. Working as a lecturer in University of Diponegoro since 2015 until now. Having a lot of publication, in 2021, the ongoing research about lesson from pandemic COVID-19 for sustainability construction in Indonesia, the mitigation of COVID-19 in the perspective of contractor for sustainable construction in Indonesia, risk analysis of project construction in pandemic COVID-19 in Indonesia. And having a lot more publication in 2020. In 2019, 2018, and 2017 that you can read out in the monitor. Being a speaker in kegiatan pembekalan kompetensi tambahan in 2021, being a speaker in bimbingan teknis dan uji sertifikasi pelaksana pekerjaan jalan in 2020, and being a speaker in kegiatan bimbingan teknis dan uji sertifikasi pelaksana lapangan in 2020. And without any further ado, Mrs. Riza Susanti, STMT, all right is yours.
Okay, thank you, MC. Good afternoon, ladies and gentlemen. Thank you so much for being here. I'm Riza Susanti, and I'm going to be your moderator for this session. For your information, that Expert Speak is a series of webinar that conducted by the Civil Infrastructure Engineering and Architectural Design Vocational School Diponegoro University, which is held once a week with the big theme is adaptation of infrastructure and design during and post-pandemic. And ladies and gentlemen, as we know that the pandemic COVID-19 suddenly has changed everything in the world and forced all sector, health, economic, also construction, etc., to adapt in a very high level of uncertainty. But it's turned out the pandemic has finally forced all of us to innovate as a form of adaptation, including in construction project. Okay, ladies and gentlemen, if last week we have discussed about innovation in construction method during pandemic, today we will discuss about innovation in asphalt as material in construction. But I'm not alone here because to discuss this topic, we have a keynote speaker today. And it is now my pleasure to introduce to all of you our guest speaker, Associate Professor Insinyur Dr. Nur Izzi from University Kebangsaan Malaysia. Okay, ladies and gentlemen, Dr. Izzi is a senior lecturer in University Kebangsaan Malaysia. And allow me to read his CV. As you can see here, Dr. Izzi was born on 24 April 1919 in Kelantan. He is from Department of Civil Engineering, Faculty of Engineering and Built Environment, University Kebangsaan Malaysia. Okay, next. Okay, Dr. Izzi was graduated from doctoral program in University of Nottingham, UK in 2012. Okay, next moderator, MC. Besides teaching in this university, Dr. Izzi is also active in several professional bodies, as you can see. His career history in here, and he is winning some awards. You can see here, the latest is in 2021. He is having award Anugerah Individu Kecemerlangan Penerbitan, Anugerah Kecemerlangan My RA 2019 University Kebangsaan Malaysia. Okay, next. As a lecturer, Dr. Izzi have a huge amount of research and publication. Okay, there's some supervision, yeah, from postgraduate. Okay, next. Okay, this is from master program. Okay, next. Okay, this is from undergraduate program. This is some publication from journal. Okay, that's so many achievement that Dr. Izzi having. You can see in his CV. And now, please welcome, ladies and gentlemen, Dr. Izzi. Hello, Dr. Izzi, can you hear me?
Yes. Thank you, Madam Riza Suranti. Yang saya hormati Ketua Program Study, Madam Asri Nordiana, and then Mr. Hassan, and then also my great Sifu, Dr. Iswandar Widyatmoko from ICOM, UK. Today I'm going to have, just a sharing session with all of you. Yeah? Let me share the slide first. Boleh padamkan dulu. Okay.
Okay, Dr. Izzi, how are you today?
Alhamdulillah.
Okay. Maybe before we move right along to the presentation, may I inform you that we will have a 16-minute presentation 16 minutes in total. So we have about 45 minutes in presentation, then we will wrap up by the question and answer in 15 minutes. Okay, Dr. Izzi, the time is yours.
Boleh nampak? Boleh nampak
yes,
slide?
Yes.
Okay.
Yes.
Okay, Bismillah, Alhamdulillah. Assalamualaikum warahmatullahi wabarakatuh, and a very good afternoon. Thank you very much to Madam Rizati.
Excuse me, Dr. Izzi, you share the presenter slide instead of the big slide.
Okay. Let me saya tukar sekejap. Dr. Darul nampak
Yes,
full screen?
full screen.
Okay. Okay, bismillah, alhamdulillah, assalamualaikum warahmatullahi wabarakatuh, and a very good afternoon. Rabbi shrah li sadri wa yassir li amri. Thank you very much at the Department of Civil Engineering, Faculty of Engineering and Built Environment, University Kebangsaan Malaysia, Malaysia. Today, I would like to take this opportunity to thank Undip, University di Ponegoro, for inviting me to this sharing session. Within the time frame given, I'll try my best to deliver my sharing session with all of you on the innovative asphalt. Okay, this is just, we go back to some background, the road history. This one, I think many of you already familiar with this Via Appia. The Via Appia or Appian Way is one of the earliest and strategic San War, but also to facilitate day-to-day transport of goods between Rome and Campania. The width of the road is approximately around 3 meters in the rural areas and 5 meters near the cities. The structures of the road had ground surface to enhance drainage and often incorporated ditches and underground drains. The next one, we have also the another ancient road we call as the Via Ignatia, was a road constructed by the Romans in 130 before century. It crossed Illyricum, Macedonia, and Thracia, running through territory that is now part of the modern Albania, North Macedonia, Greece, and European Turkey as a continuation of the Via Appia. Like other major Roman roads, it was about 3 meters wide in rural areas and 5 meters wide near cities or urban. This road is paved with large polygonal stone slabs or covered with a hard layer of sand. And this is another example, but this one we are looking for the urban highway or urban express. This is just the new Ignatia motorway in Greece. I'm taking the example in Greece. Yeah? Following this new Ignatia motorway was designed following the alignment of the old Roman Via Ignatia. The new Ignatia motorway is expected to become the backbone of the northern Greece transport system, where the length of this new motorway is around 660 kilometers. Okay, we go back to the historical evaluation of flexible pavement. Because today for my presentation, I will focus more on flexible pavement. You can see that from this figure, we can see that the pavement structures decreased from about 900 millimeter to 1,000 millimeter for Greek or Roman design and then this goes down to 350 to 450 millimeter for Telford design to approximately around 250 millimeter for macadam design, 240 to 150 millimeter at late 1800s or early 1900s. But after that, we can see an increase in pavement thickness due to the presence of heavy loads and high traffic. And then, on the right side, on the last bar, it shows that the long life asphalt pavement or perpetual asphalt pavement, PAP, which we are going to discuss toward the end of this presentation, with the layer thickness increased to about 350 to 750 millimeter. Okay, this is also some basic information about the typical pavement cross sections. Basically, we have 3 types of pavements. The first one, we have the flexible pavement. Second one, we have the rigid pavement. And the third one is a semi-rigid pavement. So normally for the flexible pavement on the left side, it consists of 5 layers. The first one, the bottom one is we call as the subgrade, the compacted subgrade, which is around 150 to 300 millimeter. And then next we have the sub base around 100 to 300 millimeter. We got the road base 100 to 300 millimeter. And after that, we got the binder cost around 50 to 100 millimeter. And the last one is we have the wearing cost around 25 to 50 millimeter. For rigid pavement, the surface cost can vary in thickness, but it is usually between 150 millimeter for light loading and 300 millimeter for heavy loads and high traffic. The semi-rigid pavement is a composite pavement material consisting of porous asphalt concrete using air voids between 25 to 30% by volume of Marshall mix design, which is filled or flooded by a special formulated high-performance polymer modified cement mortar grouting material. The major application of the semi-rigid pavement for road construction is a traffic light intersection or junction with a typical thickness of 50 millimeter as the wearing layer. But as I mentioned before, for today's presentation, we're going to focus on the flexible pavement only. Okay, what goes into the making of asphalt? So basically, asphalt is the umbrella term used in the American and European markets for a bituminous bound material. Asphalt is the shortened version of hot mix asphalt or HMA in abbreviation. Asphalt, by definition, is a mixture of coarse and fine aggregates, binder, and bitumen and filler. In general, asphalt is used for constructing and maintaining roads, parking areas, railway tracks, ports, airport runways, bicycle lanes, sidewalks, and also play and sport areas. Okay. Now I want to bring all of you to revisit, because of this COVID pandemic, COVID-19, some of us didn't get the opportunity to visit the premix production. For today, we're going to watch a video on the asphalt mixture of premix production at the hot mix asphalt plant. Actually, this video was originally taken at the premix plant at Bukit Tambun, Perak, somewhere in Malaysia. Let me share with you. All right, we go to the next slide. This is an example of the recent, this Malaysian government policies, where 5% of the new road to be constructed in Malaysia should be from
Recording
the
stopped.
concrete or rigid pavement, and
Recording in
another 5%
progress.
of new roads should be from polymer modified bitumen, and then new technology or innovative asphalt is also encouraged to be used. For example, these days the Malaysian government is promoting to use latex in road construction, or in
Recording
other words, we call
stopped.
as the rubberized road.
Recording in progress.
So there are various types of asphalt mixtures that we're going to discuss today, such as we got this asphalt concrete or dense graded asphalt concrete, AC, we got this asphalt concrete for thin ACTL, and also for the asphalt concrete for very thin layers, ACVTL. We got SMA, stone mastic asphalt, ultra thin layer asphalt concrete, UTLAC. We got a porous asphalt or open graded asphalt. And then the next one, we also have this double layer porous asphalt, 2LPA, hot roll asphalt, HRA, plastic asphalt, MA, soft asphalt. And the last one is the high modulus asphalt. Actually, there are various types of
Recording stopped.
Mixes used these days. Yeah. So this is about this asphalt concrete or a dense graded asphalt mixture. The most, if you can see here, it's mentioned this is the most commonly used type of asphalt worldwide for the construction of asphalt layers. So actually, this AC asphalt concrete was initially developed in the USA to meet the need for an asphalt resistant to heavy traffic loads and aircraft loads. It is the most well-known type of asphalt.
Recording in progress.
By almost all countries around the world. AC asphalt concrete consists of coarse aggregate, fine aggregates, and fillers in various proportions, producing dense and up to open graded mixture. The strength and stability of this mixture derive from the interlocking of the aggregate particles, assisted by the hardness of the bitumen. Air voids normally between 3 to 6%. Normally, during the construction day, we wanted the air void to be around between 6 to 8%. And after we open the road to traffic, we want the air voids to be reduced down to 4%. The next one, we have this polymer modified asphalt. Polymer modified asphalt, or PMA, is used to prolong the life and enhance the performance of the bituminous pavement layers. It is a continuously graded aggregate mixed with polymer modified binders. Polymer cover a broad range of modifiers with elastomer. For example, we have the rubber or elastic, and we also have this plastomeric type of polymers, such as plastic, being the most commonly used types of polymers. Styrene, butadiene styrene, SBS, and also styrene butadiene rubber, SBR, are frequently used elastomers. Research conducted as part of the National Cooperative Highway Research Program found that SBS is the most often used modifier. These modifiers are used to reduce rutting and to improve fatigue, and also to improve thermal resistance. So this is some of the advantage when we use polymer modified asphalt. The first one, we can improve resistance to rutting or permanent deformation. And the second one, we can improve the resistance to cracking due to binder hardening, improve resistance to fatigue cracking, improve adhesion of binder to aggregate. And then PMA also recommended to be used on high stress areas such as climbing lanes or where excessive exert loads are expected. Basically, in pavement study, we try to overcome three main problems. We try to overcome three main problems. The first one is we try to overcome the rutting or permanent deformation at high temperature. And then we try to overcome the fatigue at the intermediate temperature. And then the last one, we try to overcome the thermal cracking at low temperature. The next one, we have this AC asphalt concrete for thin ACTL or asphalt concrete for very thin layers. Asphalt concrete for thin, this one is around 30 to 40 centimeter, or abbreviated as the ACTL, or for asphalt concrete for very thin layers, 20 to 30 millimeter, or also known as the ACVTL, is an asphalt for surface courses with a thickness of 20 millimeter to 30 millimeter, in which the aggregate particles are generally gap-graded to form a stone-to-stone contact and to provide an open surface texture. This mixture is often used in France and is called BBTM, Béton Bitumineux Très-Mince. This is some photos. Yeah, some photos shows the ACVTL during its construction time in 2006. And then this is another photos show here. This photo shows that ACVTL, the photos was taken, the photos were taken in 2015, 9 years after its initial construction. And then from this photo, it was found that the road is still in good condition. Okay, the next one, we have this stone mastic asphalt, or if you refer to any others, textbook, this also called as the stone matrix asphalt. SMA is originated in Germany in the 1970s to provide maximum resistance to rutting caused by the studded tires on European road. It is a dense gap-graded hot mix asphalt with a large proportion of coarse aggregate. So the coarse aggregate is around 65%, and a rich bitumen filler mastic. SMA is characterized by its high viscosity bituminous mastic. SMA mixes have polymer modified bitumens. Normally for this stone mastic asphalt, we use polymer modified bitumen, contents that range between 5.5 to 7.5%. The PMB may be further stabilized using cellulose fibers. Of course, when you use fiber, we try to prevent excessive binder drain down. The presence of fiber enhances the durability of the SMA mix by allowing the use of higher bitumen content. And then this is the SMA is able to provide durable surfacing and exhibit high resistance to rutting due to heavy axial load. This type of surfacing also offers improved texture depth in range of 0.7 to 1.0 millimeter. And then this one is also providing good skid resistance. This SMA mixture is recommended to be used on high stress areas such as climbing lanes or where excessive axial loads are expected. However, SMA doesn't provide permanent solution to diesel spillage problem. Due to relatively high cost compared to the conventional asphalt, it shouldn't be used indiscriminately. And then the next one, we have this ultra-thin layer asphalt concrete, UTLAC, or sometimes it is also called as asphalt ultra-thin layer, AUTL. This UTLAC, I just make it UTLAC, is a hot mix asphalt road surface course laid on a bonding layer at a nominal thickness between 10 millimeter and 20 millimeter with properties suitable to be intended use. The method of bonding is an essential part of the process, and the final product is a combination of the bonding system and the bituminous mixture. UTLAC is a mixture in which the aggregate particles are generally gap-graded to form a stone-to-stone contact and to provide an open surface texture, similar with the previous one. Several varieties of this layer are often used to provide a good new noise-reducing surface layer. However, it is rarely used. This mixture is rarely used due to lack of availability and require of special paving machinery. Thus, this pavement needs high cost. And the next one, we have this porous asphalt. ataupun in Malay language we call it a turapan beliang lah. Porous asphalt is a special purpose wearing coarse produced using graded aggregate mixed with polymer modified binder or polymer modified bitumen. It contains a relatively high avoids after compaction. The design and in-place avoid shall be in the range of 20 to 25% to ensure the drainability. A minimum thickness of 50 millimeter is essential. It is important to provide adequate drainage within the porous asphalt layer. So when we talk about the normal dense graded, we are talking about 4% of air voids. Because when you pave the road, you try from water penetrate through. But for this porous asphalt, you allow water to penetrate through, so the water will seep through to the lower layer, and then, of course, normally for this porous asphalt, road, they got some, subsoil drain to drain water to the drain. Yeah, so for this porous asphalt, they got some advantages. The first one is to improve in terms of the skid resistance at high speed, especially during wet weather. We should be able to reduce aquaplaning effect or hydroplaning effect, reduce a splash and spray effect, reduce headlight reflection and glare on wetness, reduce rolling tires noise level. This when we drive on this porous asphalt, it is quieter as compared to the normal one, conventional asphalt mixture. And then this porous asphalt shouldn't be laid in the areas where the pavement structure strength is substandard. Excessive deposits of debris, oil, fuel may be experienced. Normally, the biggest problem of using porous asphalt is the clogging problem. Maksudnya dia akan berlaku lekatan clogging problems, where whenever we use porous asphalt, we need regular maintenance lah. And then free drainage cannot be accommodated along the road shoulder. Length of road less than 100 meters because of spray carry over from congestion surfacing. Reduction in spray or noise level achieved at low speed. And then porous asphalt is recommended for highways and federal roads with hydroplaning problems. And then the next one, we got this, we call it a double layer porous asphalt. Previous one, we see porous asphalt, just one layer. But this one, we got another one called as a double layer porous asphalt, 2LPA. Or I think, if I'm not mistaken, in Netherlands, this product is called as twin lay. For double layer porous asphalt, the top layer with a grain size of 4.8 millimeter is about 25 millimeter thickness, and the second or bottom layer is porous asphalt with a coarse aggregate 11/16. I was told this one is the sieve size used in Netherlands, if I'm not mistaken. The total thickness is about 70 millimeter. Because of the finer texture of the top that give less tire vibration, it gives a better noise reduction than a single layer porous asphalt. Yeah, because this one is, if we say that the normal porous asphalt is already quite quiet, this one is double, more quieter as compared to the normal porous asphalt. However, it is more expensive solution as compared to the normal porous asphalt. The next one, I think maybe Dr. Iswandaru is very familiar with this one, hot roll asphalt, HRA. Is a gap-graded bituminous mixture in which the mortar of fine aggregate, filler, and high viscosity binder are major contributors to the performance of the laid material. Coated chippings, normally single-size aggregate particles with a high resistance to polishing, which are lightly coated with high viscosity binder, are always rolled into and form part of a hot roll asphalt surface course. This durable surface layer was often used as a surface layer in the UK. Hot roll asphalt HRA takes the form of the bituminous bound mortar, consists of fine aggregate, filler, sand, and high percentage by weight bitumen content of approximately around 8%. So this one is quite high. Normally for the normal asphalt, we use approximately around 5% of bitumen or asphalt, but in this case, it used around 8%. Pre-coated high PSV polished stone value chippings are spread over the top of this bituminous mortar in a separate process using a chipping spreader and then roll into the layer using a steel barrel roller, forming the finishing hot roll asphalt surface. However, this HRA is quite expensive if we compare to the normal asphalt concrete due to high percentage use of binder. The next one, we have the soft asphalt. Soft SA is normally used in the Nordic countries or these cool climatic countries. Yeah? This flexible soft asphalt is a mixture of aggregate and soft bitumen grades. Yeah, of course, because for these cool climatic countries, we need to use soft binder in order to avoid the thermal cracking. And then the next one, we have this high modulus asphalt or HMA, a dense material with high stiffness modulus. So it provides high resistance to rutting, has good spreading ability and good durability. So basically this HMA only used for base
Recording
of
stopped.
And then if you can see that here, it's also mentioned that HMA is hot mix asphalt manufacturers using hard unmodified bitumen. So when we talk about the hard unmodified bitumen, typically we are talking about 10, 20 or 15, 25 penetration grade bitumen. And then of course this one as well as a good quality fully crushed aggregate. The key performance characteristic of HMA are high stiffness, high resistance to permanent deformation and fatigue cracking due to high bitumen content. HMA is also designed to offer good moisture resistance and good workability. But I think currently in many research for this HMA, the researchers, they also use polymer modified bitumen as the binder material, not only using the hard bitumen, but they also use polymer modified bitumen. The next one, we have the mastic asphalt. The primary features of this mixture is high filler content, high binder content, it almost zero permeability. It's very hard actually, this asphalt mixture. This use of harder bitumen is high cost primarily due to binder content incorporated. Mastic asphalt is used for protection layers and interlayers for bridges, tunnels, and rough. Mastic asphalt may be used in roads, airfields, and other traffic areas for surface courses or binder courses. In all cases, chippings are added to paving grade mastic asphalt at the end during the stage of laying. But this one, it's not many areas use this mastic asphalt. I think from my reading, one of the places used is in England. And then the next one, we have this color asphalt or color surfacing. It's a treatment with a specific color on the wearing course and may be used to differentiate the various elements. It may be used to improve the traffic flow and traffic safety. It is a resin-based surfacing with anti-skidding properties. It consists of a layer of epoxy and polyurethane mixture topped with fine aggregates. It is produced either using drum mix or asphalt batch. Colors can be normally red or green. This is the normal colors that we use for the color asphalt, red or green, but other colors are also available these days. The application of the color surfacing should be delayed for at least 28 days for newly paved surface due to the relatively fresh bitumen coating of the aggregates. This would cause poor adhesion between the color surfacing material and the pavement surface, which may result in cracking and peeling of the material. And this one is just a graphs show a comparison in terms of the durability of various types of hot asphalt. So if you can see this one.
Recording in progress.
If we can see here that it can be seen that stone mastic asphalt, hot roll asphalt, and mastic can last long as compared to other types of the asphalt mixture. And the next one, we have the current technology. that we call as the warm mix asphalt or half warm mix asphalt, WMA or HWMA. So this WMA are asphalt produced, handled, and compacted at temperatures lower than those of the conventional hot asphalt. So basically, when you use this, when we lay when we pave the road, for the normal hot mixed asphalt, you can see the smoke coming, from the material. But when we use this warm or half warm mixed asphalt, so you cannot see the smoke. See, this one is more, environmental friendly as compared to the conventional asphalt mixture. So this is achieved by lowering the viscosity. So we reduce the viscosity of the binder using some. So it got several techniques lah. The first one, we use additives. There are various types of additives available in the market these days. So these additives can be either inorganic or chemical, or we can use the foaming process, foam bitumen. We use bitumen emulsion-based process or modification of binder aggregate mixing process, all known as WMA system. The aggregate mix gradation is the same as for the hot mix for the normal hot mix asphalt. Producing and using WMA or HWMA resulting fuel consumption, environmental and paving benefits. This is what we try to achieve when we use WMA technology. So the first one, of course, we try to get the benefit from the fuel consumption, and then you can see this from the figure. It shows how the HMA and WMA fit into the full range of techniques from cold mix to hot mix, and the approximate fuel usage per type of mix. And then in terms of the environmental benefit, 20 to 35% reduction of carbon dioxide equivalent, which translates to approximately 4.1 to 5.5 kilogram of carbon dioxide per ton of mix. And then in terms of the paving aspect benefits, compaction and transportations are facilitated, paving paving seasons extended, facilitates higher rates of RAP in recycling, allow quick return of traffic. And then I think one more thing that people's researchers and paving technologists are talking these days about this pavement end of life consideration. So this pavement end of life can be defined as the final disposition and subsequent reuse, processing, or recycling of any portion of a pavement system that has reached the end of its useful life. When pavement reaches its end of life, pada penghujung lah, di punya penghujung hayat, it may first remain in place and reused as part of the supporting structures, be recycled and reused. This is what we want to do, be recycled and reused in most cases, in particular for old asphalt. So this is just terminology lah. In Europe, it is known as the reclaimed asphalt pavement. But in US, it is known as the recycled asphalt pavement. Or the last one, it may be removed and non-filled. End-of-life activities impact sustainability. So at the end, we try to go for the sustainability elements and must be considered in a comprehensive life cost analysis by considering factors such as waste generation and disposal, material use and water quality, and etc. Okay, so what's the benefits or what's the advantages if we go for the pavement recycling? So the first one, conservation of natural resources for aggregate production, but also for bitumen saving. Of course, we will use, we will recycle the pavement, so we use less of the virgin aggregate, and also we will use less of bitumen. Energy savings, mainly from energy saved during production and transportation of the materials, conservation of environment, mainly from disposal and landscape intrusion, and in case of asphalt, pollution of soil and water reservoir, and then a reduction of cost construction. But this one is depend on the project and recycling technique used. Okay, So when we talk about this recycling, so basically we have various types of recycling techniques. The first one, we talk about hot in place recycling. We got the hot in plant recycling. We got this cold in place recycling, cold in plant recycling, and the last one is full deck reclamation, FDR, full deck reclamation. But for today's presentation, I just focus on two types only, which is the HIPR, hot in place recycling, and the next one is on cold in place recycling, CIPR. So HIPR, hot in place recycling, is a rehabilitation technique that involves heating, scarifying, mixing, leveling, and compacting the existing bituminous surface. The technique includes blending scarified material with fresh bituminous mix, bitumen rejuvenating agent, apa ni kita panggil sebagai agent peremajaan, and if necessary, we have to add the virgin bitumen. So, hot in place recycling offers the following benefits. This is some of the advantages when we go for the hot in place recycling. It is an economical and practical solution for rehabilitation of surface distresses by reducing the whole of materials, usage of aggregates and bituminous mix. So because we use the recycled material, and then we can restore the right quality and surface condition of structurally sound pavement. And then in urban areas, it maintains curb height for safety, and this one is it addresses deterioration mitigated, ruts and depression, fill, shows bump level. In addition, crossbounds are also reinstated, and utilities manhole covers need not be raised. And then, since the effective recycling depth is limited to 60 millimeter only, hot in place recycling shall not be used to address pavement failures that are related to the base and subgrade layers. Like for this case, hot in place recycling, we're just going to touch for the top 60 millimeter, the thickness only from the top to bottom, 60 millimeter only. Hot in place recycling is recommended to be used to address functional pavement failures such as bleeding, raveling, surface cracking, and undulation. Not the whole. This one we try to repair to address the problem for the top layer. We're not going to go for the whole structural layer of the pavement. Next one, we have the cold in place recycling, or CIPR. CIPR is a structural pavement rehabilitation techniques involve scarifying, stabilizing, and relaying the recycling materials with minimal off-site hauling or mixing. It involves the processing and stabilizing of the existing pavement layer without heating. This one, we are talking about this recycling at the ambient temperature. Most stabilizing agent used for the cold in place recycling are bitumen, lime, Portland cement, fly ash. But I think the current one we're also using the chemical for the stabilizing agents.
I'm sorry, Dr. Isi. Could you please make this presentation a little bit fast because relative time we have this afternoon?
Okay, so this is the application of the green technology by using back the existing material in pavement construction. And then cool in place recycling is recommended for pavement upgrading work which has experienced structural failures. So this one, I think you can read it about this later, tips for improving sustainability for asphalt. And then this is the term sustainable in the context of the pavement. Okay. This one is okay. And then I want to touch a bit about this perpetual pavement, because this is very important these days, long life pavement. And also, but this one, the term LLP, the term is used by the European. And then we got another term called the perpetual asphalt pavement, PP or PAP, coined by the American. So a long life pavement is a type of pavement where no significant deterioration will develop in the foundation of the road base layers, provided the correct surface maintenance is carried out. And then an asphalt pavement designed and built to last longer than 50 years without requiring major structural rehabilitation or reconstruction and needing only periodic surface renewal in response to distress confined to the top of the pavement. At the end of the day, in both of the above definitions, one should always consider environmental and social impacts. So this is some of the benefits, that when we use the perpetual asphalt pavement. So low life cycle costs by avoiding a deep pavement repairs or reconstruction, lower cost delay costs since maintenance or rehabilitation works require lesser time, hence shorter period of traffic disruption, lower environmental impact since lesser material is required over pavement lifetime and recycling may be applied. And then this is I think it's also one of the quite interesting studies in pavement technology distance. We are talking about the cold pavement technologies. So basically, these cold pavement technologies can be divided into three types. The first one, we use the reflective pavements in order to reduce the urban heat island effect. The second one, we have this evaporation pavement. This one, as I mentioned before, water will seep through to the lower layer. And the third one, we have the heat storage modified pavements. This is something like energy harvesting pavements. Reflective pavements and the evaporative pavements. These two methods are widely researched and studied and applied cool pavement technologies, whereas the heat storage modified pavement, this one is researched but rarely applied technologies. I think because of the cost is quite expensive as compared to the first two methods. So I think this is very interesting, but if you have time, you can refer to this reference. Actually, this is a very good review paper written by a group of researchers from India. The title is Emerging Technology in the Journal of the Construction and Building Materials, very recently. Okay, so to conclude this presentation, to construct innovative or sustainable flexible pavement so the first one, the flexible, the pavement must be durable and long-lasting. So life expectancy, it should be more than 40 years. Normally, when we talk about the flexible pavement, we are talking about the maximum of design life of 20 years. But this one, we are talking of for more than 40 years. Use high-quality aggregates as close as possible to the project site. Use the appropriate bitumen or asphalt binder, like in our case. It is preferable if we can use polymer modified bitumen, which is this can retain for the heavy loads. Use appropriate asphalt complying to the requirements. Use not only empirical but also requirement. Use proper pavement design methodology to derive alternative solution. Base the final decision solution on the LCCA life cycle cost analysis. That is in terms of the economic evaluation and life cycle assessment. Environmental impacts result without being influenced by the initial construction cost. Of course, when you're talking about the initial construction cost, when you use a new material, the initial construction cost will be a bit higher as compared to the conventional one. Use compaction practices, in particular to those related to compacted density, longitudinal or transverse joints and evenness. Use latest technology construction equipment and transport vehicles. Spend the time of the year of major construction works and the days of period within a day for maintenance or rehabilitation works. Provide an even pavement with good structural responsiveness. Having a surface layer possessing good and long-lasting surface texture and good and long-lasting permeability. Apply proper and timely maintenance and preservation treatment, considering not only cost and performance, but also environmental and social impact. Consider end-of-life pavement as a useful asset which must be reused. So encourage the use of reclaimed asphalt pavement in hot or warm recycling, cold recycling primarily in asphalt maintenance or rehabilitation works, as well as in construction of unbound layers. So at the end of the day, a sustainable pavement certainly requires more capital to build, but on the long run, it is economic, friendly to the environment, and better for the society. Okay, I think that's it for my presentation. This is some of the references that I used to prepare this slide. So that's all. Thank you very much. Now I'm giving back to Madam Riza Suranti. Thank you.
Okay. Okay, thank you for the very cool presentation, Dr. Izzy. It gives new information to us about there is any innovation about sustainable, flexible pavement. I think it's very good input to us. We can learn a lot from you, from Malaysia. Okay, now moving right along, now we come to the question and answer session. So please click the feature raise hand in your screen and I will call you by name and you can deliver your question to our speaker. But first, don't forget to introduce yourself first. Okay. The first question. Okay, from Mrs. Farzanella Swarto.
Thank you, Bu Riza, untuk kesempatannya. Selamat sore, Dr. Izzy. My name is Farzanella from Diponegoro University and a student now in NTech under Gordon Airy. So I'm sorry first, I will ask a lot of questions for you. The first is asphalt. I think it's not really common in Indonesia, and you say that it will require a lot of maintenance. But what is the common of failure for porous if compared to other technologies such as hot mix, high air void? Question, Bu Riza, should I?
Let me answer it.
Okay.
Or maybe later. So I think the most problem using this porous the debris, the dust and everything. This one will go. They do the regular maintenance using the porous asphalt road. I think last time we got some trial road in Malaysia using the porous asphalt, but there's sometimes clogging problems, and then because the function of air void is to allow water to seep through to the lower layer, but because of the clogging, and then water cannot seep through, and then the roads become malfunction.
Thank you for inviting me to comment. They use sometimes the high pressure water jetting, sometimes using the air jetting to clean. But it's all depend on the trafficking. If you use it on a high traffic area, then usually it is self clean mechanism because the hydraulic action from the air compressed by the tire to remove the debris. But usually on the shoulders, that is the problem where the debris just up and clogging the water from the main roads to the drain area. But talking about porous pavement or porous asphalt in the pavement is a complex subject, because it's not just about that layer that we need to consider, but also the geometric to make sure that you've got a good drainage pattern to the collecting drain, and also there are many aspects that needs to be considered. But yes, it's a good materials to consider if you are thinking about reducing spray and noise. But there are a lot of things that need to be prepared about, especially on the maintenance aspect of it as well. Thank you.
Okay, thank you, Dr. Daru, for the response. The second question, Mrs. Nella, is there?
Yeah, the second question, Dr. Izzy. I saw that Malaysia also start using latex for polymer modified binder. But in terms of life cycle assessment, what is the impact parameter used in Malaysia? Will the toxic components such as fertilizer be assessed or only the carbon footprint?
I think I cannot answer this one because actually this latex or this because of rubberized road, this one just been introduced in our specification very recently. It was introduced in 2019.
Oh, so the same with Indonesia.
Yeah.
Indonesia also just started.
Yeah, just started, and then we got two new components there. The first one is using latex, and the second one is using chrome rubber.
Okay.
Actually, I got one friend who's working with this public works department, and then I asked this question before, and then because when they started with this project, suddenly the pandemic is coming, and then they just stopped everything. So I'll try to find the answer, because the last time when I asked them, and then they said that because of this pandemic, they didn't do anything. When they introduced this one, they have some trial day in Malaysia, and after that, so no more, no more follow up and everything. Or maybe Dr. Iswandaro have, a good experience in UK about chrome rubber, because I think he wrote one review paper on chrome rubber before.
Yes.
For rubber.
Thank you. Yeah, UK is quite unique. UK is not really up to the use of chrome rubber if we are talking about use of chrome rubber as rubberized asphalt, whereby we will be using 18 to 20% of chrome rubber content in the mix. Although recently companies started introducing chrome rubber, but not as bitumen modifier, but it's more for bitumen drainage inhibitor, i.e. if we design a stone mastic asphalt, typically we will use cellulose fiber to hold the excess binder in the mix. But in this context, a company started using chrome rubber as replacement to the fibers. So it's quite a small content of chrome rubber. Other usage, more use on chrome rubber is on the joint sealant. So if we talk about joint sealant, then that's where this kind of product has been used, latex or chrome rubber. Thank you.
Thank you.
Okay, thank you, Dr. Daru, for the response. I think Mrs. Nella still having a question to you, Dr.
One more
Isi.
question, sorry.
One more question.
One
Okay,
more
please.
question, just one more. So for the perpetual pavement design, is there any specific design criteria, Dr. Izzy, or is there any required laboratory test to see whether our mixture or design will have long service period? Because in Indonesia, we only carry Marshall stability. Thank you.
I think even in Malaysia, we are still using the Marshall. I think most of many countries, we are still using Marshall. But if you refer to super performing asphalt pavement, they already go for the performance grade specification. So this is actually what we have to go towards to. But I'm not sure about the special design, but I think the thickness is it's much more thicker as compared to the conventional one. Because even actually in Malaysia, we haven't started yet with this perpetual asphalt pavement. But this one I just took from literature review. I'm not sure. Maybe how about in UK, Dr. Daru? But I think because in Malaysia and Indonesia, we didn't go towards this PAP, perpetual asphalt pavement yet.
Yes, we've been using a long life pavement EME materials. That was probably around 10 or 15 years ago. So we have already in our design approach, it is a design for long life pavement. So you have a structure whereby it will last for a much longer than the standard structure. And we just maintain it by replacing the surface cores and all the binder cores. So it's quite easy to maintain. Yes, it's another process. It's quite expensive to start with, but in the long run, it's cheaper to maintain.
Okay, thank you very much.
Okay, thank you.
Thank
Is
you.
it enough, Mrs. Nela?
Enough. Thank you, Dr. Izzy. Thank you, Pak Daru.
Thank
Okay,
you.
maybe we can move to second question from Mrs. Asri Nurdiana, please.
Masih di mute, Bu.
I'm sorry, you still on.
Okay. Sorry, maaf. Yeah, thank you, Bu Lisa. Hello, Dr. Izzy. I have one simple question. How the process in Malaysia about adopt an innovation, so the innovation finally can be applied in the industry, because in Diponegoro University, especially in our faculty, vocational school, our students also have many ideas and also have some experiment about aspal innovation, but only stop in the document, in the document, patent, and the certificate, and so on. I want to ask only one question. Thank you.
Thank you, Madam Asri. I think the conditions in Indonesia and Malaysia is almost similar. Because whenever you are introducing a new material, and then I think the first question that will be asked is about the cost. Yeah. But of course, because now we are talking about the conventional bitumen, this is the cost, yeah. And then when you add something inside, and then the cost will be much more higher as compared to the conventional one. I think this is the problems faced by the developing countries like us. And then when the industry is, when you're proposing something, and then the industry is saying that, okay, the initial price, the initial construction cost is very high, right? And then they seems reluctant to go for this. So I think it's almost similar in Malaysia. Many ideas we keep in documents, in the books, in the shelf nicely. We didn't use it. But last week I got one discussion with one of my friends, and they said that now not for the federal highway, but for the expressway. I mean, they have started to use for example, polymer modified bitumen in order to enhance the durability of the road. But of course, this one you have to go for this. In Malaysia, you have to go for the Malaysian Highway Authority to introduce your material. If they're satisfied with this new material, and then they will do the pilot project for this one. I think masalah yang sama lah kita satu rumpun.
Mirip-mirip ya, similar ya, betul dia. Ya, sebenarnya di Indonesia itu industri ya, matching fund ya, matching fund ya, to meet the user need ya, the user requirement with the innovation from university. Yeah. Okay, thank you, Dr. Izzy.
Or maybe Dr. Iswandar want to share his experience with the developed countries. Very different. Because we are coming from developing countries, it's different.
Well, in principle, is the challenge is the same, i.e., whether this innovation can fall within the existing specification or standard within that country. If in the UK, within the UK. If the innovation is outside the scope of the specification, then that is where a long process needs to be considered. For highways work, we have adopted this technology readiness level, whereby there will be a transfer from the responsibility and liability and cost bearer from the stage 1 or level 1, level 2, level 3. For example, that's from whoever have the idea that will develop the idea and prove the idea to the small scale, theoretically, and then to the lab scale, and then move to the next scale using the demonstration trial, and then start engaging with the authority to do the network level, and then negotiating with the authority to put that as a new specification or any rule that can allow the material to be used in the network. So that's quite a long process. It may take 5 years or more from the idea to actually going into fully adoption. The quick win is the approach that Dr. Izzy has presented, i.e., if we have a project, Indonesia perhaps toll project, whereby the contractor, it is a design and build a project, for example, whereby the contractor has got consultant in-house, and then they will take all the responsibility if there is anything wrong with the asset. Usually that make it easier for innovation, because if anything's wrong, the contractor will take the responsibility. So as long as between the one who have the idea, the consultant and the contractor, they are into that together, then that can speed up the process. I think that's in brief what we have here in England.
Okay. Okay, thank you for your sharing, Dr. Ismail.
Thank you.
Okay, let me see. There is no question. Okay, limited time we have in this afternoon, so that is marking the end of our question and answer session today. Thank you, Dr. Izzy, for the response, and also Dr. Daru for the response this afternoon. Now let me give you some highlight from our discussion today. Nowadays, there are so many innovation in pavement technology, as mentioned in presentation of Dr. Izzy. And closing statement for this session is a sustainable pavement certainly require more capital to build, but on the long run is economic friendly to the environment and better for the society. I think that's all for this session. Thank you to our honorable speaker, Dr. Izzy, for the very powerful presentation. We look forward to seeing you at another event or maybe some research and publication collaboration. Thank you for all the wonderful participants and the committee. I wish you all a pleasant day and thank you very much. Good afternoon.
Thank you, Dr. Izzy. Thank you,
Thank you, Dr. Izzy, Dr.
Thank you.
Daru.
Terima kasih semua.
Thank you.
Assalamualaikum.
Waalaikumsalam
warahmatullahi
wabarakatuh.
Okay, I think this is a symbolized certificate from Diponegoro University to Dr. Izzy as speaker today in our webinar series. Once again, thank you, Dr. Izzy, for sharing session this afternoon to us. It gives us many input.
Once again, thank you to Dr. Nur Izzy and Mrs. Riza Susanti for guiding the material for today's seminar. And before we moving along to the next agenda, we have documentation section for all the participants here. So all participants here, please turn on the camera and use the virtual background that's been provided. Diperkenankan juga untuk panitia untuk bisa meng-capture dan mengambil gambar untuk sesi dokumentasi kita kali ini. Apakah panitia sudah siap untuk mengambil gambar? Mungkin saya langsung saja akan saya hitung. 1, 2, 3, 1, 2. Thank you for all participants. And once again, thank you to Dr. Nur Izi, Dr. Iswandaru, and Mrs. Riza Susanti for all the time and all making time to join us here and sharing a lot of knowledge also for the insight for this afternoon. We hope that this event will be a place to gaining more ideas and developing our ideas and knowledge in the field that we mastered in.
Moving along, we have a special game for you, but before we move to the next agenda, we're pleasing all the participants to fill in a presence link that has been linked in the chat room, or you can scan the barcode that have been provided by the committee on the screen. For your information, that we have limited time for the presentation. You have 5 minutes until the link is blocked. Maybe for the committee, please show the presence link barcode.
Mbak Zara, Mas Dio, kalau sudah saya lihat ya.
Baik, Bu Asri. Terima kasih.
Baik, Bu Asri, terima kasih.
Okay, thank you, Komite. Thank you once again to Dr. Izzy. See you on next collaboration.
Thank you, Mrs. Santi.
Okay, good
Terima kasih,
afternoon.
Mas.
So, saya boleh left ya?
Iya.
Makasih
Yes,
ya,
yes,
insyaAllah.
please. Thank you.
Okay, thank you.
Thank you semua,
Assalamualaikum.
Dr. Nurizi. Waalaikumsalam.
Semangat panitia dan peserta.
Terima kasih semua ya.
Diperkenankan untuk peserta bisa memindai barcode yang sudah tersedia di layar atau bisa mengisi link presensi yang sudah tersedia di kolom komentar.
Okay, the time is over to build the presence link. Yeah, making this evening more exciting and unforgettable. We are having special games for you. So without any further ado, let's get started.
Oke, teman-teman semua, di sini gamenya akan dijawab bersama sembari menunggu teman-teman yang mungkin belum bisa absen mengisi link presensi yang tertera di kolom komentar. Kita bisa melanjutkan ke sesi selanjutnya. Akan ada sedikit games. Bener nggak, Salsa?
Oke, bener banget dong, Kak. Ini kita bareng-bareng ya. Mungkin bisa lanjut nih ke slide selanjutnya.
Oke, langsung aja di soal pertama, aku sebagai gambar kali ini. Oke, ada 3 gambar nih. Ada gambar kucing, ada gambar apa tuh? Ada gambar glue, ada gambar juga book. Oke, mungkin ada teman-teman peserta di sini yang bisa ngejawab pertanyaan pertama. Bener, nggak usah malu-malu. Kita di sini refreshing dari materi yang sudah disampaikan tadi. Kita sekarang refreshing di kuisnya.
Iya, kita senang-senang. Mungkin ada dari teman-teman yang bisa menjawab, bisa raise hand.
Aku mau jawab, Kak. Oh, nggak jadi, udah dengan tangan nggak jadi.
Oke, mungkin dari angkatan 19 Aprilian Dini. Bisa dijawab?
Cat tembok.
Cat tembok. Oke, terima kasih.
Wah, ternyata
Oke,
benar
bener banget.
nih.
Selamat kepada Aprilian Dini sudah bisa menjawab pertanyaan.
Di sini.
Nggak sabar, kita langsung aja masuk ke soal kedua. Oke, ada gambar apa tuh? Gambar pertama, gambar kedua ada store, dan gambar ketiga ada truck. Oke, mungkin teman-teman ada yang bisa menjawab? Atas nama Dias Agil, silahkan untuk jawab pertanyaan keduanya.
Jawabannya foto konstruksi, Kak.
Foto konstruksi, kita lihat panitia.
Coba deh kita lihat. Wah,
Foto konstruksi. Wah, selamat Dias Agil, jawabannya benar.
Selamat Agil.
Dan kita langsung aja masuk ya, salsa ke pertanyaan ketiga, silahkan dibacakan. Oke, ada sin kos, sin per kos sebenarnya ya. Ada gambar, ada tulisannya expert. Dan yang terakhir jawab untuk soal ketiga, kuis tebak gambar kali ini.
Ayo, siapa yang mau ngejawab nih? Kayaknya
Oke, mungkin lagi agak mikir ya soal. Oke, karena mungkin ini teman-teman menyerah sebelum berperang ini. Karena kelihatannya belum. Oh, ada akhirnya ada. Angkat dari
angkatan 20 ya?
Iya, angkatan 20.
Pandemi bukan?
Pandemi. Oke, kita lihat apakah benar.
Kita lihat nih jawabannya.
Oh, sayang sekali.
Ya, ternyata.
Sayang sekali, tapi nggak apa-apa. Jawaban aslinya adalah tanah liat, tapi karena ini eksperti juga mengangkat tema pandemi, jadi pandemi dibenarkan juga lah ya untuk soal kali ini.
Bisa. Masuk akal ya, Kak Dio.
Lagi. Oke, kelihatannya ini kita masuk ke soal terakhir nih, Salsa. Iya nggak?
Wah, harus cepet-cepetan nih, Kak. Kalau enggak, ya nggak kebagian dong nanti.
Bener. Oke, soal terakhir ada jempol. Ada gambar jempol. Oh, belum selesai dibacain soalnya udah ada yang bisa ngejawab. Dari Naval Adil mungkin?
Wah, tumbal proyek.
Apa?
Tumbal proyek. Yang bikin soal ngawur.
Oke, coba kita lihat jawabannya. Apakah benar tumbal proyek? Amazing nih.
Ternyata
soal belum selesai dibacakan udah dapat nih tumbal proyek.
Keren banget sih, keren banget. Oke deh, Kak Dio. Tapi sayang banget ini last question ya.
Iya, ini last question, sayang banget.
Mungkin buat next time teman-teman ya bisa untuk
lagi.
Untuk yang minta lagi, mungkin minggu depan bisa join Expert Speak lagi nih, karena minggu depan juga pasti ada banyak games seru yang udah teman-teman panitia siapin dan kita bakal main seru-seruan di next week's international seminar.
Iya, bener banget nih, Kak Dio. Oke deh, mungkin kita bisa lanjut ke next agenda ya, Kak. Ladies and gentlemen, now we're on the last agenda for today's seminar. I'm Zara Safabila Jindana Putri and my partner.
I'm Dear.
As the Master of Ceremony representing our friends and the comedy activity this evening, we would like to say our deepest gratitude and say thank you to all participants, attendees, and invited guests who have been willing to attend this event. Let us close the seminar, Expert Speak Series 2021 with Devon as Health Innovation, Adaptation, Infrastructure, and Design during and post-pandemic. But before we close the seminar, this event ran perfectly with the support of our sponsors and media partners. We're thanks to Event Campus Go, Pelajari.info.id, Blog Mahasiswa, Ruang Mahasiswa, Event Jutek, Lembaga Pers Mahasiswa Manunggal Universitas Diponegoro, Lembaga Pers Mahasiswa Cakrawala Sekolah Vokasi Universitas Diponegoro.
Event Kampus, Badan Eksekutif Mahasiswa Sekolah Vokasi Undip, HMA Amogasida Fakultas Teknik Arsitektur Universitas Diponegoro, Himpunan Mahasiswa Sipil Universitas Diponegoro, BPR 3 Omah, dan Forum Komunikasi Mahasiswa Teknik Sipil Indonesia. And don't forget to join us in the next international seminar, Expert Speak Series 2021. And keep updating with us on Instagram at Expert Speak Undip, and we're waiting for your presence on our next week's international seminars. And good day, everyone. Stay healthy, stay positive, and good vibes only. Wassalamualaikum warahmatullahi wabarakatuh, and we'll see you very, very soon.
Halo semuanya, selamat datang di jurusan Teknik Infrastruktur Sipil dan Perancangan Arsitektur yang biasa disebut sebagai Pilar. Sebelumnya kenalin, nama aku Adam Rizky Jadafa
dan aku Adelia Zahra dan kami dari angkatan 2019.
Every industry has been touched by COVID-19 impact. This pandemic being challenged, especially while constructing. As we know, asphalt closely related with construction industry and mostly used in pavement construction. Currently, there's a lot of technologies that we can take advantage of. The asphalt using in pavement construction has a lot of innovation and development, such as eco-friendly manufacturing, which being developed to have less of an impact on environment. Every industry has been touched by COVID-19 impact. This pandemic being challenged, especially while constructing. As we know, asphalt closely related with construction industry and mostly used in pavement construction. Currently, there's a lot of technologies that we can take advantage of. The asphalt using in pavement construction has a lot of innovation and development, such as eco-friendly manufacturing, which being developed to have less of an impact on environment. Every industry has been touched by COVID-19 impact. This pandemic being challenged, especially while constructing. As we know, asphalt closely related with construction industry and mostly used in pavement construction. Currently, there's a lot of technologies that we can take advantage of. The asphalt using in pavement construction has a lot of innovation and development, such as eco-friendly manufacturing, which being developed to have less of an impact on environment. Every industry has been touched by COVID-19 impact. This pandemic